Hey everyone, welcome to homework 4.13. So today we looked at how to write an equation from the graph that we see. And so I'm going to start by going over the homework and then I'll go back and look at a couple of the classwork problems. So we're matching the graphs here with the equation. And so we want to look and see what will make this graph change. Well, notice we only have one graph with a negative coefficient, and that is graph C because it has a downward facing U. It's open downward, which means it has a maximum. And so that would be equation 2 and graph C, matching very nicely. So then we need to determine between 1, 3, and 4 which graph matches what. Well, another way to look at this is to think about what our x-intercepts are and whether that makes sense for the graph. So notice that for graph B, we have a much wider x-intercept range here, and we can see that in the way that we have these two graphs here. So let's look at this. This would be the same as x times x plus 1. This would be the same as x times x minus 1. And this would be the same as x times x plus 3. So notice here that our x-intercepts here would be 0, negative 1, 0, positive 1, and 0, negative 3. And looking at those, that can help us to match these graphs a little bit better. So this would have I shouldn't have written it like that. I just realized that's very confusing. My apologies. Oh, and now it doesn't want to erase. Cool. Okay, well, while that's thinking, I should have written those as two separate points. So 0, 0, and negative 1, 0. So I realized the way that I wrote that was confusing. But you'll notice then that the only one that has a positive x-intercept is number 3, and the only place we see that on the graph is graph D. So let me rewrite this: 0, 0, negative 1, 0. Now that my computer's not frozen anymore. This is a recurring theme here. Okay, so this would be 0, 0. The other one would be 1, 0. And then 0, 0, and negative 3, 0. Sorry, I think you clarified that there. Okay, so number 4 then matches very nicely with graph B. And that leaves 1 and A, which makes sense. We have negative 1 and 0, 0. All right, now here again, we're going to need to factor to do this. The thing that all of these have in common is that x. So we're going to factor out the x. What's left is x plus 12. That means my x-intercepts will be 0, 0, because we'll set this to 0 and we'll set this to 0, and 0, negative 12. And then the x-coordinate of the vertex then is between those two, right? So 0 plus negative 12 divided by 2 gives me negative 6. So that's the x-coordinate of the vertex. So same thing here, factor out that x, so we'll have x minus 3, that's what's left. And I know that I'm factoring this out. I can check my work. If I multiply through and distribute, I get x squared minus 3x, which equals this equation here. So again, setting each of these to 0, we have x equals 0, or we have x minus 3 equals 0. Therefore, my x-intercepts are 0, 0, or 0. Oh my gosh, I keep doing this. Let me fix this. I did it wrong up here too. Sorry, negative 12, 0. That's our y value is 0. All right, and then this will be 3, 0. And then so to find my x-coordinate of the vertex, we'll do 3 plus 0 divided by 2 is 1.5. Okay, now here, this is a little bit trickier because we have a negative in front of here. So what we're going to do is we're going to factor out the negative x. So we'll factor out negative x times x. Now, to get a positive 16, I have to multiply it by a negative. So this is negative x times x minus 16. Again, set each one of those to 0. And so we'll have 0, 0. And 16, 0 as our x-intercepts. And then 16 plus 0 divided by 2 gives us 8. So that would be the x-coordinate of the vertex, that point in between. Now notice because this has a negative x, this would have a downward open facing graph, and these would have upward facing graphs. All right, same thing here. I'm going to factor out the negative x, and I'm going to be left with x plus 24 in this case, because a negative times a positive gives me a negative. So negative x equals 0, and then x minus 24, or sorry, x plus 24 equals 0. So then our points are 0, 0, and negative 24, comma 0. 0 plus negative 24 divided by 2 gives me negative 12. All right. Here is a graph that represents y equals x squared. Describe what would happen to the graph if the original equation were changed to x squared minus 6x. Predict the x and y intercepts of the graph and what quadrant where the vertex is located. All right, so if we were to redraw this one, we can also factor this out to be x minus 6. This gives us new x-intercepts of 0, 0 and 0, 6. So notice that it's shifting over. And then what else do you think will happen? Will it also shift up or down? Well, if we were to look at the vertex, then it would be along x equals 3. And if I plug 3 in here, I get 3 times 3 minus 6, which equals 3 times negative 3, which equals negative 9. And so that does mean now my vertex is down here. And this means that my graph looks like this. So it's shifted over and down because of this linear term here that we've tacked on to the end of x squared. So we sketch the graph, and then you can describe it would move, and then you fill in what we just talked about. How would it move there? Okay? All right, that'll help show me that you are listening. Select all equations whose graph opens upward. All right, so for this one, I'm going to say the answers, so that was weird. Listen. All right, so a negative x squared plus 9x means the coefficient is negative, and so that would open downward. This would be downward facing, so it is not that one. The next one is interesting because it's written with the 10x first. So you would need to rearrange this to make it negative 5x squared plus 10x. And there you'll see that actually the a term, right, in the coefficient of x squared is negative, which means that this would also be facing down. Now here, this one is written out not in expanded form. Remember that this is the same as 2x minus 1 times 2x minus 1. And so this would give us a positive answer for our coefficient of a. And so C is an answer. You should circle C. For letter D, let's rewrite this. Now notice what's going to happen. These are written backwards. So let's see what happens. We'll get 2 here, and then times plus x. Then negative x times 2 is negative 2x. And then negative x times positive x is negative x squared. So you may already notice that this negative coefficient of x squared means that this is actually going to be opening downwards. And so this is not an answer option. And the last one, E, is already written in quadratic form. You can see that it has a positive value. So E is also an answer in which the graph opens upward. Upward meaning smiley face, right? So it's positive. So you could circle E. All right, write an equation for a function that can be represented by each given graph, then use graphing technology to check each equation you wrote. All right, so here we're going to be using this formula y equals a times x minus h times x minus g, or whatever variable you want to really put in there, but those match the two x values there. So a times x minus 0 is one of them. And then the other one appears to be 7, x minus a negative 7. Okay, now that negative is important because this is part of the equation, so we write our minus, and then it's a negative 7 we're inputting there, so that becomes a positive. So we'll get y equals a times x plus 7. And now if we want to find out what a is, we need to plug in a point that we know and see what that see what that will create, right? And that will help us to determine what A is. So looking at this, right, you want to think about what point could I put in here that would help me to test that. Well, let's say I try to put in 0, 0 here. I would get y equals A times 0 plus 7. Now, anything times 0 is going to give us 0, right? So that is not going to work out as a number or value that we can use here. Instead, you would want to use something that has a little bit more value to it that's not going to create a 0 for us. So we could, for example, use what looks like it would be, we know that we have 7 and 0, so it would be -3.5 is 1 point. And then it looks like -12 here. So -3.5 comma -12 is one of our possible answers to plug in here. So we can rewrite this as -12 equals A times -3.5 times -3.5 plus 7. This is -12 equals, and so we'll have, let's see, -3.5 times -3.5, which is A times positive, nope, this will be positive 3.5, so -12.25. And so then we'll divide 12 divided by 12.25, and we're going to get A equals a very strange number here. So A equals 0.979. And so that's not the most beautiful equation, but it gives you an idea of how you would do that. All right, so once you have your equation, you still need to be able to solve for A and figure out what's going to go in front there. We might honestly assume that 1, because that's 0.979 is very close to 1, that we could just write it as such. My computer keeps freezing. Okay, so we could rewrite this as y equals, we assume A is 1, x minus 0 is just x times x plus 7, so y equals x squared plus 7x. All right, let's take a look at this next one. Here we have -4 and +4. It's open upwards, so we should have a positive coefficient. And then it looks like it crosses the y-axis as 0, -16. So we can set this up as y equals A times x minus 4 for this one, and then x minus -4 for the other one. So y equals A times x minus 4 times x plus 4. Now, if I need to solve for A, I can plug in this value here. So we can do -16 equals A times 0 minus 4 times 0 plus 4. And you may already recognize that this is going to equal -16, so A is going to equal 1. All right, so you can just rewrite this, get rid of that A as 1, right, which is times itself. So our equation is this one right here, and you can rewrite that in standard form by foiling or using your box method, whatever you're more comfortable with doing. And we'll get x squared minus 4x plus 4x minus 16. Notice these will cancel out, and you'll get x squared minus 16. All right, and then this one here, same thing. We're going to set this up. Y equals A times x minus a -9 times x minus 3. We'll get y equals A times x plus 9 times x minus 3. And then here it's a little bit harder to see this point, but it looks to be about there. For this one, I'm going to go ahead and just assume that our A is 1 as well. And so if you were to rewrite this, you could rewrite it as x plus 9 times x minus 9 and put it into your calculator and see what happens. See if it matches this or not. Okay? and that can help you to determine if you would need to determine a coefficient for A. All right, number 6 is match each quadratic expression that is written as a product with an equivalent expression that is expanded. Oh, sorry, this is written not very well. So you're matching the top with the bottom. Oh, sorry about that. That's a little bit of a formatting thing. So here is just matching your quadratic expression. You can use your square method. Or you can use FOIL. All right, so this will help you to see that this is x squared plus 7x plus 12. So A matches with H. All right, B let's see, x squared plus 10x plus 21. Okay, and so you can continue to match those and finish this on your own. That is a bit of a review. All right, number 7 is when buying a home, many mortgage companies require a down payment of 20% of the price of the house. What is the down payment on a $125,000 home? So 125 times, this is just 20% of the home, not 20% plus, so 0.20, and then calculate that. All right, number 8, a bank loans $4,000 to a customer at 9.5% annual interest rate. Write an expression to represent how much the customer will owe. So here it says write an expression. Notice it's not asking us to solve, so 4,000 is our starting amount. It's an interest rate, means it's increasing. So this is 1 point. This is 9.5% interest, so 1.095 to the power of 5. Because it's annual per year. So we can say f of 5 years equals 4,000 times 1.095 to the power of 5. All right, number 9 is a park practice problem. This is an example of a problem that is on the park. And so here is the graph. And then it says there's this new graph where A and B are constants, and the graph is now shifted up and over. What are the values of A and B? So what caused it to move up and over in that way? And so it wants you to figure out what those are to make your equation shift in the way that it has. So first of all, here, it looks like it has gone up how many? 1, 2. So it's gone up 2. Right? Because it's gone now to 1 from -1. So this is important. It's gone up 2. So that's something to notice first. And then secondly, it has gone to the left over here. And so it's moved over left 1, 2, 3 spots. So left 3 spots. Or in other words, it's gone -3 spots. So the question it's asking you is, what would I be adding to this equation to make it look like that? So from that we can reason, we know that B, right, adding that to the equation is going to move it up. And so we're moving it up 2. And then we're moving left 3 spots. But remember, we're minusing a minus, right? So this is the same as x minus -3, right? And so we are actually going to be adding a 3 within that parentheses, because adding that 3 would give us a -3 for this point moving over here. So if you think about where our vertex is, going from -1, sorry, 1 comma -1, 1 comma -1, oh my goodness, 1 comma -1, there we go. And then moving to having a vertex of -2 comma +1, we see that we've moved over left 3 spots, and then we moved up 2 spots. All right. If you have any questions, feel free to let me know. Your code word for today will be microwave. Microwave is your code word for today because our affix for this week is micro. Feel free to reach out with any questions. Happy homeworking and see you tomorrow.